Okay, last problem for this lesson. If I look at this one, here's my original. I don't have anything to reduce in this one. Nothing cancels top and bottom, so I do not have any holes. None. Nothing cancels out top and bottom, no holes. Vertical asymptotes. What can I put in the denominator that will make this 0? Or set this equal to 0. Well, if I set this equal to 0, I would get x equals 0. So I know I have a vertical asymptote at 0. And I'm going to draw that in right there. Draw it in as I go. Now for my domain, no holes. So that means my domain would be negative infinity up to my asymptote. And then from my asymptote to positive infinity. Okay, next I want you to pause the video, try the x and y intercepts on your own. Remember, x-intercept is when y equals 0. Y-intercept is when x equals 0. Try those, and then when you come back, you can check if you're right. Okay, for your y-intercept, set x equal to 0. So I have 0 plus 1 over square root of 0 squared. So simplify that. I got dividing by 0, so no y-intercept. For my x-intercept, set y equal to 0, so I set the whole thing equal to 0. Once again, like we talked about in the last video, I multiply by my denominator, so it multiplies by 0, so your denominators will always just go away. So that's why we get the shortcut of just set the numerator equal to 0. So I solved that out and got negative 1, 0, and then put it over here on my graph. Okay, we're going to do end behavior as a class, because the end behavior for this one is a little weird. So I have end behavior as I go to the right, positive infinity, and end behavior as I go to the left, negative infinity. Now I'm going to do what I did before. When I look at infinity, what is inconsequential? That 1 is not going to make a difference. So I end up with x over square root of x squared. Now, some of you might be wondering, Mrs. Johnson, why haven't you simplified this square root of x squared yet? They just cancel out. Well, here's why. Because if I'm looking as x goes to positive infinity, and as x goes to negative infinity, I need to be careful. Because this is going to simplify to x over plus or minus x. It will depend. Because I have that square root, I have that plus or minus in here. So if I think about plugging in positive infinity, I would get a positive infinity over a negative infinity. Sorry, nope, I'm thinking of that wrong. Checking my notes. So as I think as my positive numbers, I would get my positive infinity over positive infinity. So that's my positive end behavior. But now if I'm plugging in my negative numbers, that's going to get me my negative end behavior. So anytime you have a root in here, your end behavior is going to be different based on if you're going left or right. You can kind of think of it shortcut way is it'll be the positive root to the right, the negative root to the left. So this means my end behavior, color code them, to the right, it's going to positive 1. To the left, it's going to negative 1. Now, let's practice our sign line. So on my sign line, I have negative 1. That's the first place where it might change from negative to positive. I have 0, my asymptote. It could change places. And it looks like that's it for this one. This one's a much simpler one. And in fact, if I know that my end behavior has to go this way, I can double check on my psi line, but if I'm left of -1, it should be negative. So let's plug that in and see. So -2, let's say, -2 plus 1 is a negative. -2 squared is a positive, and then square root of that is a positive. So that worked. We got a negative. Practice your sign line between -1 and 0 and greater than 0. See if you get the right signs. Pause it and try it. Okay, this is what you should have gotten. Positive, positive. You can double check my work here. See if you got something wrong. You can pause the video and check it out. So that tells me if I need to be positive between -1 and 0, then I need to be above the x-axis for -1 and 0. So I'm going to cross through my x-intercept, and I have to go against my asymptote because I can't cross it. Now this last part from 0 on all needs to be positive. So I'm going to run along my asymptote, and I have to end pointing at my end behavior. So that's our graph for this one. If you want to use our shortcut hand, -1 would have been this part, which has an exponent of 1, which is odd. So it would cross through the point. And the asymptote of 0 came from this part, which is squared. So it's even. So that means they both had to point up, or both had to point down. And because I knew this one had to cross through, it had to go up, then I know this one would have to go up as well. So once again, those shortcut versions do work. That's it for 1.4. Go ahead and get started on your assignment.